Climate. Why in the world do we have different climates? Well, there are a number of different factors that go into all of this. Number one could be wind currents. Wind currents can affect our climate and why we have warmer temperatures in Miami, Florida, rather than colder temperatures that we have up in Canada. So wind currents are one of those things. So there's an important term here called convection, and convection can affect the wind currents and the temperature there. It's basically the transfer of heat in the atmosphere from one location to another. So if your mom has a convection oven at home, it kind of works the same way, where there's one source of heat and is going to continue to recirculate that heat and warm up other parts of the oven. That same thing happens when it comes to wind currents. We have a source of heat, namely the direct sunlight, and then those wind currents are spread throughout all of the rest of the globe, and it helps to warm up these other parts of the earth that are not getting those direct sunlight rays. We also have the Coriolis effect. This is the bending of wind currents as the earth rotates.
You probably don't spend a lot of time thinking about how water drains from your toilet, but somehow the idea that water drains differently in the northern and southern hemispheres has made its way into our collective consciousness. Furthermore, the reason for this phenomenon has been pinned to the Coriolis effect, which refers to the way the Earth's constant eastward rotation influences how we view the trajectory of certain moving objects. Because the diameter of the Earth at the equator at 40,076 kilometers is so much greater than it is at the poles at 0 kilometers, the land of the equator is moving lots faster than the land everywhere else, about 1,638 kilometers per hour at the equator compared to about half that at 60 degrees north latitude and pretty much stationary at the poles. And yes, the Coriolis effect, named for 19th century mathematician Gustav Coriolis, does indeed influence objects traveling across the face of the Earth due to this constant eastward rotation. If you tried to throw a baseball from the equator up to your friend standing at the North Pole, your ball would appear to veer to the right, because it would maintain the greater momentum of the place it started from. On the other hand, if you were throwing the ball to the South Pole from the equator, the ball would appear to veer to the left for the same reason. So although the Coriolis effect is totally a thing, the application of this principle to draining water in Earth's two hemispheres is just bunk. Our planet spinning around once every 24 hours isn't a big enough deal to affect a toilet that takes 5 seconds to flush. Basically, the direction water drains is dictated by the shape of the basin it's in, the sink or toilet bowl or whatever. The Coriolis effect does, however, influence bigger, slower-moving fluids, global air and ocean currents, for instance, which can end up giving hurricanes their spin. If the Earth didn't rotate on its axis, among the very many and unpleasant things that would be different, one of them would be that winds wouldn't blow either west or east. They'd flow from the poles, which are naturally high-pressure areas, to the equator, where there's low pressure, and back again. But the Coriolis effect deflects these winds to the right in the northern hemisphere, to the left in the southern hemisphere, which creates weather systems that rotate clockwise in the northern hemisphere and counterclockwise in the south. The Coriolis effect, working at that scale, does affect entire climate patterns.
Now, ocean currents are also an important factor that could affect climate. Very similar to the way that wind works, the ocean currents can do the same thing. Warm water is going to flow away from the equator toward the poles, and cold water is going to recirculate back to the equator. And as the winds blow over the current, then it can also affect the land, because the wind is going to pick up either the cold water or the warm water and is going to blow over top of the land and therefore affect the climate of that particular region. Now, the zones of latitude can also affect climate. We have 3 zones of latitude here. The first one is low latitude, or the low zone, also known as tropical. And these are any of the zones in between the Tropic of Cancer and Capricorn. So on either side of the equator there. And so naturally that's going to be really, really warm. It's hot all year long in this low zone. The middle zone is very temperate. And this zone is going to be between the tropic lines and the polar lines of latitude. And so we would live in one of these middle or temperate zones, and we're going to have a wide variety of temperature in the middle zone. Then the last one is the polar zone, and this one is very much near either the north or the south pole, right on the top or right on the bottom here. And what you're going to see is that you're going to have cold temperatures all year long, very cold. Then the fourth of the factors affecting climate is going to be elevation. So as altitude increases, you get higher and higher up, and in our Earth, you're going to see the temperature goes down. So the temperature drops about 3.5 degrees every 1,000 feet that you raise in elevation. And that would be important to remember as we move along here. So 3.5 degrees every 1,000 feet that you go up, it's going to get colder. Now, topography is the last of these that affect climate. The landforms can affect climate, especially mountains. So keep in mind those 5 things that do affect different climates. Now, climate can change from time to time, or can have short periods of change among the climate. That does not mean that it's always going to be that way, but there are certain explanations for that. One of those is El Nino.
I am El Nino. All other tropical storms must bow before El Nino. Yo soy El Nino. For those of you who don't habla español, El Nino is Spanish for the
El Nino is the warming of the water on the west coast of South America. And what happens there is we have a change in wind direction, affects the ocean temperature, and it greatly affects the United States specifically with more moisture and warmer temperatures. And so we'll see this every few years where the El Nino comes along. We have warmer temperatures, we have more moisture, sometimes we can get more snow, or perhaps instead of snow it becomes more rain, and that happens periodically and it affects our climate that we wouldn't normally have. La Nina is exactly the opposite. It's the reverse of El Nino, and so we're going to see a reduction in moisture along both North and South America as a result of this phenomenon. Now, some would also talk about global warming here, and I think it's important that we do discuss it just briefly, but really we need to understand where it's all coming from. But we look at global warming as the increase in global temperature. There's all kinds of groups, organizations that are trying to determine why is our Earth getting warmer and why are we having climate change and all these things. But scientists go back 125 years and they have figured out that the global climate has increased 1 degree over the period of that last 125 years. But they are predicting that over the next 100 years, it's going to increase about 3.5 degrees or so. And most people attribute that to the greenhouse effect. And the greenhouse effect is simply the fact that we are producing and burning more coal and petroleum, and as we burn those things, it is releasing warm gases in the atmosphere that get trapped, that can't escape out of our atmosphere. And so those continue to bounce back and forth between the atmosphere and Earth's surface, and therefore it stays warmer than what it ever has before. And the big concern for those that are really concerned about global warming is that it's going to continue to melt off glaciers and the ice caps, and therefore the oceans are going to raise higher and higher, and it's going to affect our coastlines. So that's really all I'm going to say about global warming at this point, and we may go into a little bit more in class. So make sure that you have understood each of these topics as it pertains to climate, and the factors affecting climate are especially important.